welcome back to my channel. So today I'm going to explain the search insert position problem. So this problem also called as a lower bound. So this lower bound problem you already saw, but if you are not get this lower bound things, I will explain now. Okay. So just remember, if this is simply the binary search problem, like I'm going to find out the mid, and that mid element should be greater than or equal to the target to insert that particular position in that. So first let me explain the problem statement. So the problem statement is, so they gave an array 1 3 5 6. So in this array you want to insert the 5. So if you want to insert 5, what will be the position? So the position will be the 0, it's a 0 based index. So 0 1 2. At the 2th position you are going to insert the 5. So you want to return the position. 2 is the position where you are going to insert the target value. Okay. So I'm going to use the lower bound technique to solve this problem. So just remember this. If that array element is greater than or equal to the target, I'm going to store that answer. I'm going to take the answer variable. I'm going to store it that, and I'm going to shrink towards the left side, because I want to insert 5 in this order, right? 1 3 5 6. So it should be in ascending order, and you should insert. So in these examples also, you want to insert 2 between 1 and 3. So the position will be 0 1 position. So you want to return that output also. So I'm going to dry run and show you how it will work in a lower bound method. So let's solve this problem using simple syntax of this. You just want to remember this formula. So there is no way to understand this. Just remember this middle element is greater than or equal to target, which is a lower bound. Okay, let's try run this. So I'm going to take the answer variable and initialize to the length of the array. Here the length of the array is 4, so I'm going to initialize to the 4. Okay, then I'm going to take the lower variable, which is pointing at the 0th index, and higher variable I variable, which is pointing at the last index, which is n minus 1. So now I'm going to find out the middle element using this formula, low plus I divided by 2. So here I will get the mid as 1. So eventually 0 plus 3, 3 divided by 2, which will give me the answer 1.5. So I will consider 1. So integer part only. So 1, the middle element is 3. So I will check whether the 3 is greater than or equal to the target. Here target is 5. I'll check. So no, the 3 is not greater than or equal to the 5. So if it is not, I'm going to move towards the right. I mean, I'm going to make the low pointing in front of the mid, which is mid plus 1. Okay. Then here I'm going to find out again the mid value. So the the low is 2 and the high is 3 only. So 2 plus 3, 5. 5 divided by 2 will give me the answer as 2.5. So I'm considering 2. So in this, middle element is pointing towards same as the low. Okay. So here the middle element is 5. I will check whether the 5 is greater than or equal to the 5. So yeah, it is not greater but equal to the 5. So if it satisfies that condition, you're going to update the answer value as that position. I'm going to update it with the index 2. I will store the mid index value, which is 2. Then I'm going to move the pointer towards the left. Okay. Then I'm going to move this I to the mid plus 1, which is here. So when the low and the I crosses, so that ends the loop. Then you are going to return the answer, which is 2, to the output. So this is a simple easy problem you can able to solve if you try run for 1 or 2 times. So let's solve another problem also. So in this array, the size of the array is 4. 4 element is there. So the target is given as 2. I just want to find out the position for inserting the target. So here low will be the at the starting index 0 and the I will be at the last index 3. I want to find out the middle element using this formula. So the middle element is 3. So I'm going to check whether the 3 is greater than or equal to the target, which is 2. Yeah, this 3 is greater than 2. If it satisfies the condition, I just want to add that index to the answer 1. Then I'm going to move towards the left because I want to find out the some of the smaller because this is a greater element, right? So just I want to find out the smaller element for inserting the position. That's the main logic is there. So I'm going to move the I to the mid minus 1, which is now I will be pointing same as the low. Middle element is 0 only. So I will check whether the 1 is greater than or equal to 2. If they does not satisfies, I just want to move the low to the right, which eventually the loop will be over and the answer is 1 should be returned to the output console. So let's code this in a LeetCode. So this is the problem search insert position. Given a sorted array of a distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. So same thing what I explained. Yeah. So let's code this up. I'm going to I will take variable as n and store the length of the array. Here the array is nums, means number. Yeah. Now I am going to take low and initialize to 0 and high, which I will initialize to n minus 1. And I am going to take one more variable for storing the answer, which is n. So I'm going to start the while loop. Here you can guess the while loop logic also. Like it should not be crossing. It should be low should be smaller than or equal to high. So then I'm going to find out the mid value. Here low plus I divided by 2. So after getting the mid element, I am going to check whether the mid index element is greater than or equal to the target. If it is, then I am going to store that index in answer and I will move towards the left because I want some more lesser element. So mid minus 1, or else I just move towards the right, which is I'm looking for the bigger element. So at the last I'm going to return the answer. So let's run this and check whether it is passing every test cases. Yeah, let's submit. So that's all for today's guys. Thank you for watching. If you like this video, please subscribe and share.